All right. So were you present last week class? Olumide. Hello? Oh. Oh wow. Yeah, but no, it's been completed and uploaded online. So but this is the part two. Yeah, this is the part two of it. Mm, okay. Okay. So maybe this is the part two of it actually, and it's like it builds upon last week. So maybe after this one, you can just go through that one. So that if there's anything that you will not get here, you can ask, right? Yeah, that's clear, right? Okay, so let's just you can see my screen. Let me just confirm before I start. Yeah, yeah, yeah. Yes, yeah. Since you mentioned it, so this is what we'll be using today, and what we're going to be doing is, or rather, what I try to do in today's class is, I try to create examples that are easy to relate with, so that can help understand the topics. So what I'm basically going to be doing is I will probably read through this and then go to I have a second screen here. Yeah, I'll just walk you through example and try to explain what's happening. And then if you're familiar with free code camp, there are exercises that you need to do after each topic. So you will be the one to do the exercise. We'll do it together. So basically, you just tell me this is what I think you should do, and then we'll try it. And then if it's right, you know. If it's not right, you also know. And again, you know that we need to pass each exercise to go to the next topic. So yeah, I'm really, really, really depending on you to progress in this topic. So your concentration is really, really needed. All right. So since you said you were not around, let me just go through this. Let me just go through this. Creating a function. So I said the function. Creating a constructor function in JavaScript is almost like creating the same function. It's like creating normal function in JavaScript, yeah. But then you just need to use capital letter for it when you're starting it. So this one that you're seeing right here now, this function human is constructor function for creating human objects. And then here what I try doing is I tried populating things that I know are common to human being, adding it to the prototype. I tried adding it to the prototype. So that's just what I did. What I did here. Now prototype. Okay, let me read this for you. I don't know if it's okay. Okay, I was trying to read something about prototype. So prototype are like the recipes. I call it like in using free code camp words. They're like the recipe with which we create an object. So if I create a particular object from another object, you get to see that later in the course as we go ahead. If I create a particular object from another object, like for example now, this is human, and then I'm saying like what I have here, I'm saying let man equals to new human. So what's basically happening is that I'm copying everything that's related to human. I'm copying it. So it's like making a photocopy. So it's like making a photocopy. You are copying everything that is in human, transferring it to man. You get, so that's the reason why here I can say um here I can say Okay, let me know communication first. Since I've copied everything that's in human to man, I can now say console.log console console.log say man dot should I say eyes. So you can see it's telling me that man has two eyes. Yeah. So that's because everything that's contained in human objects has now been transferred to man. So that's just like the rundown of how you can create objects and then use it to create new instances. So I think just trying to summarize some of the things that happened last week so that you can at least be able to follow up with where we are right now. Because from where we are today now, this part is saying that, yeah, this part is saying whenever whenever you modify the prototype of an object, whenever you modify the prototype of an object manually, you need to set the constructor because modifying it automatically with resets its constructor back to object. Now object is like the father. Object of prototype is like the father of every prototype in JavaScript. You get, so it's like the beginning, the origin. It's like the origin of everything object prototype in JavaScript. So if I let me show you what that means is right here now. If I comment out this constructor human, right, and then I say let me comment this one out, and then I say console.log man.constructor equals human. Basically, what I'm saying in this statement is I want to check if oh yeah, I want to check if this man this man is an instance of human, right? So I want to check if this man was created using the human constructor. That is what I'm trying to do here. Do you understand that? Mm, okay, so that's just what I'm trying to do here. So if I run it, you see it's telling me false. But right here you can see that actually we created man from human. But if I try to check it here, it's telling me that it is false. It's saying that it's false. That's because this particular this thing, the constructor for this man, it has reset, it has been modified. It's no longer saying it as man because I manually modified or updated the prototype of human. So if I use it as object now, you see it's telling me it's true. So it has reset back to the base. So and this part is saying that you can fix this problem is basically when you are modifying the prototype, manually adds the constructor. Just add this property, say constructor is equals to human itself. So if I do this now and then I say man of constructor equals to human, you see it's gonna give me true. Gives me true. So that's just basically that's what that topic is about. So it's like saying now that I have this object called human, and I want to create different a number of human from this object human, or let me say I want to create a man and a woman, say two gender from the human object, and then if I go ahead and do it, if I go ahead and do it, and I don't add this constructor dot, like I don't specify the constructor for this particular human object, JavaScript is going to be saying it as that man or those instances that I created. It's going to be saying as if it was instantiated from something different. It was instantiated from the from normal JavaScript objects. You get, so to fix that problem, you need to use you need to use what's name? I don't know what do you mean by what name? Sorry, I'm sure of. Yeah, constructor comma. Yeah. Mm. Okay, I think I get your question. Okay, so basically, what's it say? If you modify, that's when if you modify the prototype manually, if you modify the prototype manually, right? You need to specify it. You need to specify. Assuming this thing wasn't human, assuming this thing was say animal, then I need to specify. I need to specify this constructor as animal as long as whenever I want to check, if I want every instance that was created with this animal constructor, if I want them to have the constructor as animal, then I will need to set it. Yeah, so it's important that you manually set it as you won't get it. Yeah, exactly. Thank you. So it's going to be animal dot prototype equals to you now open the prototype object and then pass in what you want. You get that, right? Okay. So since you get that, let's fix this problem here. This part is saying define the constructor property on the dog prototype. So this is the dog prototype. Dog has already been created here. The dog has already been done here, and then the prototype has been modified here manually. So this part is saying for us to move from this document to the next one, we need to define the constructor of dog to be dog. So how do you think solve that? Okay, constructor. It's not equals to dog, it's column, but then you get oh yeah, so that's it. So that's how you modify. Okay, so understanding where an object prototype comes from. But it's actually just a story. So just like people inherit genes from their parents, an object inherits its prototype directly from the constructor function that created it. So that's just basically what we were talking about just now. So yeah, for example, here is the bed constructor creates. So here the bed constructor creates the doc object. Like we have this bed constructor, and then we created a new doc from it. You say doc inherits the prototype from the bed constructor function. So you can show this relationship with the is prototype of method. So when you do bed dot prototype dot is prototype of dog, it should give you true. So coming back to this part where we have man, and then we created man from. So yeah, let me return this to human. Human, yeah, okay. So we created man from human. So you say the way you can check the prototype of an instance that you created is to use the object dot prototype dot is prototype of, then you pass the new object that you created from it. So that's basically saying we start with human. So let me say console log console log this. We start with human dot prototype dot is prototype of now pass man. So if everything's correct, I'm supposed to see through there. Yep, true. Yep. Okay. You mean the first example I did? This this one, right? Yeah, this one. Then we're checking the constructor just to be sure of. It's something relating though, just to be sure of that. Um, You're checking the constructor that's created that particular instance. So it's basically the same. It's basically similar. Mm. Oops. Okay. So you get that bias now. The way you can check the prototype of an object. Mm. So now you say use its prototype of to check the prototype of beagle. So how do we solve this problem here? So what should I do? So here we have dog as the parent object, and then we have this beagle as the child object. Now I want to check if this particular one is if the prototype is of dog. So how do we do that? Like that? Let me check. Let me see go. Okay, that's right. Okay. So I'm waiting. Let me know when you're done. You're ready, right? Okay. So now we are in the understanding the prototype chain. So like I was trying to explain earlier, all objects in JavaScript, he said with a few exceptions, have a prototype. Also, an object prototype is F is an object. Like we've seen just now. This object's prototype is assigned to another object on its own. You know what object is now in JavaScript now, right? Okay, okay, okay. So moving on. He said because a prototype is an object, a prototype can have its own prototype. In this case, the prototype of bed.prototype is object.prototype. Now, object.prototype dot is prototype of bed.prototype. How is this useful? You may recall blah 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 blah, blah story. Basically, the prototype chain, the prototype chain that I was trying. If you remember when I was saying that object.prototype is the base prototype of every object prototype in JavaScript. Yeah. So this is like the chain now. This the chain now here. So if you see where a new instance of bed was created here, where a new instance of bed was come on, where a new instance of bed was created here, right? Now this is a child of bed prototype, and bed prototype here is a child of objects.prototype. Yeah, so it's like this is the grandparent. This is the grandparent of doc. Why Bay.prototype is the parent of doc. You understand? So that's how the chain is. So if I for example create another object now from doc from doc, that object now becomes the last child. So it's now be like this is the great grandparent of the doc object. while the bed.prototype becomes the grandparents of the doc object. And then, okay, yeah, in bed of, yes, exactly, yeah, you can do that. That was what we did. That was what something similar that we did here, which is human.prototype with its prototype of the past man, if you remember. Yeah, yeah. Okay, so the okay, let me just read this part. It said the has own property method is defined in objects.prototype, which can be accessed by beds.prototype, which can then be accessed by doc. So you can see the relationship there now. So this is everything that is in this grandparents is accessible by the parents, and then it's accessible by the child. So this is an example of the prototype chain. In this prototype chain, bed is the super type for doc. In other words, the parent for doc, while doc is the subtype. Object is a super type for the bed. In other words, the parent type for bed, for both bed and doc. So it's an object is a super type for all objects in JavaScript. Story. Therefore, any object can use the has own property method. Okay. So it said modify the code to show the correct prototype chain. Now we have dog, and then we have bigger, and then we have dog the prototype dot is prototype of this. Now I want to check now what the prototype of dog is. What should we do here? Remember, this is the child. This is okay, okay, yeah, you get it. I just want to explain. So go ahead. Yeah, that is prototype of. So let's find out. Yay! Mm, mm. No, it's checking. If check is checking if I'm going. Let me show you. Um. Uh. Let me create an object. Say let's you equals let them equals to. I'm doing this. I say name. Let me use student, yeah. Now saying name is me. First name is me, and then second surname is, come on, is you, right? So this part I saying doc dot has own property checking is basically say console console.log student that has own property f name. Um, student that has own property human. Oh, true. Now what is basically saying is it's telling students, it's saying students, please help me check if this key f name exists in you. Yeah, it's like me sending you to your room. I'm saying, Olu, please help me check if there is a television in that room. Do you understand? Or I'm asking you, Olu, please, do you have a bio? Help me check if you have a bio. So this is basically checking if this particular key f name exists in students. That's what it's doing. Yeah. Yep. Okay. So right. Okay. So using inheritance so you don't have to repeat yourself. I think for this one I tried creating. Let me comment this out. Yeah. Let me comment this one out. Okay, now see this. I have human, hmm? And then human has these properties. Now I have students. Students is another object on its own. I have students, and student has these properties, right? Now every student is a human first, right? Okay, we'll come back to this. Inside this prototype, no, it won't. It won't. So can you answer? Can you see the screen? Yeah, it's not. But if I do it inside here, if I do it inside here, and say for example I pass something here, and then I can now say this dot name equals to name. I can do this. So this right now is it will be referring to the particular object, the instance. How do I put this now? Oh, let me use example here. So have I deleted it? Uh, so if I create a new instance of human, if I create a new instance of human, say let man equals to human new. Yeah? In this particular case, okay, I don't have this here. If I use name, it means that this is actually broad. But in this case, yeah, yeah, this, okay. So I was saying, generally, the use of this is not just limited to this alone. It's broad, but in this particular case right now, huh, this this is referring to each instance that you create. Like for this one now, like for this one, and I'm saying let man equals to new human, and then I pass in say Femi. So this right now, eh, is telling me is referring to this object, this new object I'm creating. So it's saying that okay, this particular object called man, the name is Femi. Do you understand? So if I go and create another, if I go and create another object, and I call this one say Bumi, the this now is no longer referring to this. The this for this particular object now is now referring to woman, woman. So in this case, this will now be referring to this particular new object. You know, so in that case, there's no clash between them. Okay. Yeah, this is a way to. But then, if you check the class for last week, There is also a use of class itself. Although under the hood they are all the same thing, but then there's a keyword where you just do you assign class instead of using function. We call it a class. Yeah. Okay, for this particular one. Yeah, if I wanted, this is a constructor. Constructor are they are mainly used for assignments. Constructor are mainly used for assignments. You get so. Assuming I wanted to do something. I wanted to. Do you take? Okay, let me know the verse. Assuming I wanted to do like for example, okay, for this one right now, using looking at this student constructor, I passed all of this, right? I passed all of this. So I'm basically just assigning these values to it so that saying constructor is the first thing that will run whenever any object is created. So in order for you to run this constructor now, you must pass these things, you must pass these parameters to it, pass these values to it, else it will not run because it's expecting these values for it to run properly. You understand? Yeah. So using inheritance. Okay. Okay, using inheritance so you don't have to repeat yourself. Yeah, back to what I was saying. I was saying every student, every student is first human, right? Every student is first human. And these are the properties that belong to that will be defined for human already. And these are the properties that will be defined for I think network is slow. So these are the properties that will be defined for students. Now, because I don't want to repeat these things again, because I already know that all students must have two eyes, basically like in yeah, it's normal for every student to have two eyes, two legs, and it's abnormal for student to have four hands. So let me change it to two hands. So and I don't want to repeat all of these again. I don't want to repeat all of these again on that student. What I rather do is I'll create I will create I will assign the prototype of students to that of human so that everything that is contained in human can be transferred to students. So how I do that? I'll do this with saying object dot create human dot proto prototype, right? So now before I go there, let me show you something. Let me do let's student one. Let me create an instance of students. Student one equals to students. Pass the name, say Femi. Femi, department, um, make engine, level, say swan rate, school or AU, and then gender, male. Are you following? Are you still here? Okay. I just created a new student object now, and I passed all of these properties to it. Yep. Yeah, go ahead. Okay. Oh, Alfred, welcome. Yeah, I can hear you. Can you hear me? Welcome. Yeah. We've really not missed much though. Is we just started not too long ago. Okay, we're in last class, Alfred. Okay. Uh, well, it's not. I mean, like when we say last class, it's like last class from the very beginning, like forever and ever. This is the very first class. Oh, this is actually week 11. So I think yes, yeah, like 10 weeks behind. But everything is. Oh, oh, okay. Yeah. Uh, yeah. So, but then the good thing is everything is available in on YouTube, so you can just see if there's anything you missed that you want to catch up on. Yep. Yeah. Welcome. Okay. So before you joined, I was talking about inheriting properties from supertype so that you don't have to repeat yourself. And what I've done so far is I created two objects, one for human, one for students. And then for human, I passed the things that are basic. You have two eyes, you have two legs, and then you have two hands. And then for students, I passed things that are also basic. Your department, your level, your school, your gender, and then your name. Now, I was saying every student is first a human being before a student, right? So that means every student is supposed to have all the properties of a human being. In other words, every student is supposed to have two eyes, two legs, and two hands. But then, if we check this guy here, this student one here, we just created a new a new instance of students now. And then, if we check the students, this student guy here, I'm saying, let us find out how many legs does this guy have? Those legs. Let's student. Let me see. Um, Name. So what's happening? Oh, sorry. New. Okay. Can you guys see here? It's silent. Okay. Sorry. It was just absolutely it was super silent. I just wanted to be sure. Alright. So we just created a new student object, right? And the name the student that we created is Femi. And now I want to check how many legs does Femi have? Undefined. Femi does not have leg. Oh. How about eyes? Femi does not have eyes too. Why? Because we've not um students did not inherit, even if it's expected that students is human being, but this particular student right now does not have the attributes of does not have the properties human of a human being. So how can we fix that? We can fix that by assigning the prototype of students to be equal to the prototype of human being. That way, everything that's present in human being will now be copied. If you remember when I was saying something about photocopying, will now be photocopied into students. Then so that we can be able to access them. So that student dot prototype equals to object dot create human dot prototype. And when I do that, So when I do that, now you can now see that when I do student one dot eyes is giving me two. Now eyes was not defined in students. It was only defined in human. You get, but because I've copied everything, I've inherited the properties of human being. Students now has all everything that's contained in human being. So that's why when I create a new class, a new object from students, I can access everything. I can access everything. So if Olu, this for you right now. Going back to the previous topic, we want to say something about prototype chain. Yeah, yeah. So human becomes what parents of student one. Uh, yeah, it's the super type, but I used the name for it so that it's easy to understand. I said parents, grandparents, and child. So okay, yeah, exactly. So everything contained in human flows down through students down to the students one object. So that's how you can use inheritance. So basically, yeah, 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 sure. Oh, okay. Yeah, well, that's fine. That's fine. Um, the focus today actually is all being in JavaScript. You get, so like so was saying earlier, you just try and some bit of knowledge that you may have missed in previous class, but then it's okay to ask question. Even as I go right now, if there's anything that you don't understand, if there's anything I don't understand, just ask it. Then I'll try and see how I can. Maybe in the process of me trying to explain, I can now maybe touch in some things that have been said already that will help you understand better. Is that okay? Yep, yep. And then again, just try and pay as much attention as you can, because Alfred, he's been the only one doing it before now, but now he gets that too. So I think he'll be okay. He'll be glad to share the task. So basically, what I'm trying to say is I will do the explanation, and then there are small exercises after each explanation that we need to try. So basically, you guys, it's just the both of you that will be doing it. So you tell me what to do, and then I do it, and if it works, we proceed. If it doesn't work, we try and find out why it's not working. Is that okay too? All right, all right, yeah. Okay. So this part saying this exercise here right now is saying it says the eat method is repeated in both cards and bear. It says edit the code in the spirit of do not repeat yourself, which is dry, by moving the eat method to the animal super type. So basically what they did here was they created first a super type animal, and then they added this describe to it. Sorry, before now, this bait object had this describe in it. this bed object, this dog object again has this describe in it, right? Just like when I was saying, I didn't have to repeat all of this inside students again because that'll be me repeating myself. So what I used um was inherit from human beings so that I can have everything that I need from students. Yes. So I could have as well just copy this one and then put it inside put it inside here. Sorry. I put it in a prototype. I could have as well just copied everything and add it to the student prototype, but then that would be me repeating it myself. So that's what they're trying to prevent here now, because right now if you see, they've repeated this, they copied this and then added it to base prototype, and then they also copied this and then to dog prototype. So they're trying to prevent this from happening right now. So what they did was they rather created a super type called animal, just like I created a super type here called human, right? And then they added everything that's common to animals right now to them. The describe is common. So they added it to animal so that by the time birds inherit from animal and dog inherit from animal, they can both have this function accessible to them. So that's basically what they did there. So now our task right now is saying that it this it function is common between cat and bear. So we need to solve the problem so that it will be all it just be found in one place and then we don't have to repeat ourselves. So we have the cat and we have the cat the prototype, and this is the it function. We have the bear, the prototype, and then this is the it function. And then we have the human and the human dot prototype. So what should we do? Alfredino, Olumide, do I have to copy it? Yeah, go ahead. You didn't get it. Should I go ahead again? Okay. Basically, we are trying to prevent um, repeating the same piece of code in more than one place. You get? We're trying to prevent it. So, yeah. So, bed initially had this describe function. Dog again has this describe function. So, if you can see, it's basically the same thing. It's basically the same piece of code, right? So, what they did to prevent that from happening, what they did was they created a super type and then added the code to the super type, right? And then remove the code from each of these. So you can see here right now we also have constructor dog and constructor bed. So that was after removing this, you're left with constructor dog, and after removing this, you're left with constructor bed. And this that you removed from here was added to this super type. So that's basically what they want us to repeat here. So this is the first object. This is the prototype with the it function. This is the second one. This is the prototype with the it function. Now this is the super type human, and then this is where we should put our code. So they are saying that we should write. They say the it method is repeated in both cat and bear, like you see here and here. Edit the code in the spirit of dry by moving the it methods to the animal super type. So basically, they want us to move this. They want us to move this to animal super type. So it's simple, just cut and paste, then delete. Do you understand? Exactly, yeah. So I'll cut this and then paste it here. And then I'll remove this from here. Then I move this from here, then I submit. Alfred, do you understand? Okay. Basically for this particular topic, we just basically just implementing the dry. What's it called now? Is it uh okay, okay. All right then, no problem. That's fine. That's fine. Okay. Inheriting behaviors from supertype. This is all still similar to everything that we'll be doing. Then in the previous challenge, you created a supertype called anima that defined behavior shared by all animals. Animal type is that. Now, in the next, this and the next challenge will cover how to use the method of anima inside bird and dog without defining them again. It uses a technique called inheritance. This challenge covers the first step. Make an instance of supertype or parents. You already know one way of creating an instance of animal using the new operator, which is this. So then he went on to say there are some disadvantages when using this syntax for inheritance, which are too complex for the scope of this challenge. Instead, here is an alternative approach without those disadvantages. So this was what I did when I was creating, yeah, when I was doing this initially. Now it's a object dot create object creates a new object and sets object as the new object prototype. So obj rather, object dot create obj creates a new object and sets obj as the new object prototype. Then we recall that the prototype is like the recipe for creating an object. By setting the prototype of animal to be the prototype of animal, you are effectively giving the animal instance the same recipe as any other instance of animal. So all of those English, what it's saying is that just because I said students, if you remember what I was doing when I was trying to explain this, before I did this, I couldn't access the legs of the students. It was giving me undefined, right? So it's this particular line, yeah, this particular line is saying by setting the prototype of animal, blah blah blah. It's basically saying because I added this student of prototype because I added this line of code, I am I am just copying everything that's here and giving it to students. That's basically what it's saying about this English. That's what it's saying. Because I created a new so because I assigned the prototype of students, which is the instance of student one, to be the prototype of human the prototype of human. Student one can now access everything that's contained in human prototype. That is what it's talking about. Now, yep. So in this particular example, animal was done here, and then animal dot prototype was dot it was defined here. Now, when you create a new instance of animal was done here, a new object, a new animal object was created here, and then because this one was done, animal could not access the it function that was defined in animal dot prototype. So it's saying now use object dot create to make two instances of animal and name dog. Animal named dog and Beagle. So I think I should put this one for you so you can see. So this is basically what they are telling us to do. They are saying we should use this method object.create to create two instances of animal and name them dog and Beagle. So basically we are just to repeat this line of code, but then change the object instance name already have it here. Say left dock and left bigger. So in there and Alfred, what should I do? Passing what? Where did you get where did you get bed from? No, this is what they said we should do. Animal. Distance of animal. Yeah, yeah, that's it. You understand, right? You understand? Yeah. Are you still updating yours? Are you still updating yours? Okay. So again, this is everything that the last topic and this particular one, everything that we are talking about is all what we've done here. That's what they're talking about. They say in the previous challenge, you saw the first step for inheriting behavior from the supertype or the parent animal, making a new instance animal. This challenge covers the next step, sets the prototype of the subtype or the child, in this case bird, to be an instance of animal. So in other words, now we have two constructor functions. One is animal, while another one is bird, just like we had here. One was human, and then another one was students. So again, they repeated this, created a new instance. Sorry, they assigned the prototype of bird. They assigned the prototype of bird to be the prototype of its parents object, which is animal. Right. Remember that the prototype is like the recipe for creating an object. In any way, the recipe for bed, in a way, the recipe for bed now includes all the key ingredients from animal. Just like just like everything of students now include all the key ingredients for human after we did this, if you remember. Uh, so now let's doc equals to new doc.it. Doc inherits all the animal's properties, including the it method. It's just the same thing like we did. The student inherited everything from the human properties. So again, modify the code so that instance of dog inherits from animal. Do you understand? Modify the code so that instance of dog inherits from animal. So big O right now is the instance of dog, but they want it to also inherit from animal. So what should I do? The solution is here. So what should I do? Your solution is here. How should I go about this? Are you still there? Hello, Lunde. Alfred. No, so can you hear me? Hello? Oh wow. Oh wow. Um, should I stop the video or I should still keep recording? Is there pause? I'm only saying stop here. Understand first. Okay. 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 Yeah, I think, yeah, okay. Yeah. Yeah, that's where it stops. So how should I? Bird or dog? Yeah. Yeah. So we want to apply this to this animal and dog. This one bird now. So what should it be? Alright. So basically, this is the child, this is the parents, and this is the grandparents. So in our case right now, this is the child, this is the parents, and this is the grandparents. So they want the child, yeah. So they want us to assign the prototype of, yeah, yep, yep, yep. That's it. Okay, reset an inherited constructor property. Remember initially when I said if you manually modify the prototype objects, it resets it what's it called now? It affects the constructor of that particular object itself. So that's what's coming back here right now. He said when an object inherits its prototype from another object, it also inherits the supertypes constructor property. Here's an example. Function bed.prototype equals to object dot create animal.prototype. Let doc equals to new bed. Now doc dot constructor. Uh, uh, okay, let me come back here. Let me come back here. Okay, so now I have let student equals to this, right? So yeah. So if I say student dot constructor, how far it'll come back? Yeah, no problem. No problem. So if I say student dot constructor plus equals student, I get false. I get false. Why? Because if I say human, what do I get? I get true. Why? Because this constructor was defined here in dot prototype, right? And then students inherited from human. Remember, when you inherit, you are inheriting everything that's available there. So student also inherited the constructor of human. So now student now thinks that these students one right now thinks that it is this particular constructor that created it, the human constructor that created it. Meanwhile, in the real sense, it is the student constructor that created it. You get, so that's what it's saying here. That you need to reset the constructor after you inherit. Just like we said initially, when you manually modify the prototype, you need to set the constructor manually. So how we can resolve this problem right now is we need to set say student dot prototype dot constructor equals to student. So when I do this and then I check again, it's going to give me false. But when I check if the constructor is equals to students, it should not give me true. Yeah. So it's just like a repeat of what we did earlier, just assigning the constructor manually. Yeah. Mm, not absolutely. I don't get what you try to say. That's what I mean. Okay. You are thinking like, say I have two role objects. Say one is admin, one is say maybe user, right? So and then no, not let me not say admin and user. One is super admin, then one is like a lesser admin, right? That's what you mean. So that's okay. Yeah, it can. I think if you find a way to apply it, if find a way to apply it. So that means you'll be checking in your check, you are checking to see if the constructor, if a particular user was created by the super admin constructor, then you need to give it some roles. But if it's not, then you need to limit it from access to some roles. That's what you're saying, right? But yeah, if you find a way of applying it that way, it can also work. Yes, so yeah, also yeah, you have a lot of privileges. Yeah, it can also, if I end up applying that in role management, it can also work. It can also work. It can also work. But the only thing is that when you are inheriting everything from super admin. You get so that means you will strictly be checking for the constructor. You should be checking for the constructor instead of the properties that are available to it. Yeah. So yeah, back to our problem now. The task is a fix the code so that dot constructor and Bigo dot constructor return their respective constructors. So doc is bird and Bigo is dog. So how do we fix this? And bird has already inherited from animal and dog inherited from animal. So yeah, dog. No, it's not dog. No, it's not dog. This is what we are. This is what we want to do. Yeah, it, yeah, yeah. And then we do the same thing for dog. Yeah. So this one is adding method after inheritance. A constructor function that inherits its prototype object from a supertype constructor function can still have its own method in addition to inherited methods. For example, birds is a constructor that inherits its prototype from animal. So this is the super type right now. Then this is the child, right? Then animal dot prototype is inheriting from sorry, bird dot prototype is inheriting from animal dot prototype. So in addition to what is inherited from animal, we want to add behavior that is unique to bird object. Here, bird will get a fly function. Functions are added to bird's prototype the same way as any constructor functions. So just like we did bird.prototype.constructor, now we want to add a new function to it. So it's going to be bird.prototype.fly, and then you pass in, you define the function that you want. So right now, when I create a new instance of bird, you will now have this fly function, bird.it and all of that. So do you understand that? Do you understand, or you prefer I should create and show you with an example? Sorry, yes to which one? You understand, or I should use an example? And you can hear me? Okay. So let me just I'll copy this. Let me copy it. Yeah. All right. Yeah, I can hear you. I can hear you. I can hear you. I can hear you. Okay. So let me show you. Let me use. Yeah, I can hear you. I'm showing an example. So like the network is slow. Can you hear me? Hello, can you hear me? Yeah, I think so. Okay. So here's the example here. So here I have animal, and then I have it defined, the it function defined in animal. Hmm? And then here I have bed, and then bed is inheriting from animal, just like we'll be doing all this while. All the prototype is coming from animal, and then we are resetting the bed prototype constructor to back to bed, which is the previous example that we just did now. So now we want to add a new function to bed. So we'll now say bed, just like we did here. Where was it? Where is it? Yeah, just like we did with this constructor here. We'll say bed dot prototype equals to what can bed do? Bed can fly, right? We already have it there. Equals to fly. Then we say equals to function. Say console.log. I am I am flying. I am flying. So now when I do you understand this much currently? Okay. So now when I now create alright. So when I now create a new instance of bed, say hen new bed. Hen can now fly. I am flying. You get. So this particular function was not in bed before. It was not in bed before when we defined it. Neither was it in animal. We inherited from. So we just manually created a new function. We just manually added it now right now to the bed prototype. So hen now has access to the fly function. So that's basically what it's doing. Do you understand? Okay. Yeah, go ahead. Yeah, I can hear you. This is what you're saying. This is what you're saying right now. Like bed comes down and then I've already created new beds, right? So we are saying if I can run this one, it will still not work. Is that what you're saying? It still works. Yeah. Okay, so let's fix the problem. Now it said add all necessary code to dog objects. So you add all necessary code so the dog object inherits from animal and the dog's prototype constructor is set to dog. Then add a back method to okay, this is two. Let's do this part first. This part is basically what we're doing since really. So you say we should add unnecessary code so the dog object inherits from animal. So the first task here is to inherit from animal, right? So how do we can you say about we inherit? Sweet. Sweet. Yeah, the next thing is to set the constructor of dog to the dog. So how do I do that? Yeah, sweet. Custom. Custom what? Okay, so no, it's just dog. So we've done this part, yeah, we've done this bit now. Now we are now here. So then add back methods to dog so that the beagle can both eat and back. The back method should, okay, let's do this part first. Add back methods to dog. So how do I go about it? No, no, I'm missing it. I'm missing it. Um, let's take a step back. This part said, blah, 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 and the dog's constructor prototype is set to dog. Now, the way we did the setting was this, that constructor equals to dog. Now, this was constructor, that's what we were setting, right? So that's why we did dog dot prototype dot constructor and we set it to dog. Now, this part now is saying, that we should add back to dog. So what should we do? Yeah. No, 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 no. It's a function we are creating. Let's add the function. Yeah. Is that easier? Okay, let's send it. Yippee! Okay, now in the way again. Yeah, yeah. Alright. So override inherited methods. Yeah, override inherited methods. Mm, let me do this. Let me use this one to explain. So we have this animal, right? We have this animal, and then in animal we defined it, right? And then it is supposed to consider num num num. That's fine. Now we came to bird, and then we inherited from animal, So that means now it right now is now available in bird, right? Okay. Now overriding inherited method. This is what it is. I can change this. You see, remember how to add the methods to an object now? What just did just now, right? Okay. So now I want to add its methods to bed. So what do I do? Yep. Okay. So equals to function so does log I can I can hit so okay. Now if I call hen, and now we created a new object hen, right, from bed. So that means now hen has everything contained in bed and everything contained in animal. Now this is the problem. Animal has it exactly. So I think I should have really written wahala wahala wahala. So here now has here now has wahala. So which function is it going to call? If I say hen dot eat, what is it going to call? What do you think it's going to call? Let's find out. Okay, he is going to call the eat in the prototype base, but then it's not because of constructor. Let me show you. Let me tell you why. I can eat, so that's what's here. Yeah. But if I comment it out, if I comment it out and I say it, it's going to consider num. That's what's here. Yeah. So now let me explain this. Yeah. Think of it as you are in the story building. Huh? You're in the story building. You are in the first floor, and I tell you, Olu, please go to go to the top floors. I didn't specify any floor. I say go to the top floors and get me a cup of water. Right? What will you do? Will you jump to the last floor? Exactly. You go to the nearest floor and check if there is water there. Right? If there's no water there, what will you do? Exactly. Just keep going until you get to the floor where there's water. That's exactly what's happening here. So when I say hen dot eat, hen will now go, JavaScript will now go and now take hen and say, okay, is there it in this particular object bed? If there is, it's going to call it and it's going to ignore every other thing. If there was it here in every other thing, it's going to ignore all of them. It's going to call the first one that it found. You understand? Yeah. So just the same way that you understand the way this thing works, cascading in CSS when you're arranging your what's it called, your style, exactly when you're arranging it, you get. So it's just the same concept. So I think cascading starts from top to bottom, right? And but this one starts from bottom to top. Yeah, I think so. So you understand now why it's called this and not this. Yeah, because top to bottom. Are you referring back to your previous? Are you referring to your previous question? This part, this part. Okay, you said yeah, yeah. It calls what defines first. Yeah. Okay. What object is it? They say what? like why it worked after it was defined. Um, I don't think I have an answer for that right now. But then let's see. So this particular bed that was defined here. So you're saying that one define this one here, one define this one here is still new bed, yeah. Wait. I think let me undo. I think you help me understand what you're asking. Let me undo to where that question was. Oh, really? Really? Okay. Does fly. I we added a new function to base. Mm. Okay, so when we did hand of fly, it still works. That's what you mean. I am flying. Okay, so you are saying because this one was already defined, instantiated here, and then we added it here. It's not supposed to have it. Well, I don't know. I don't think that's how it works right now because I mean it's working. Yeah. No, it's not coming from top to bottom. Oh. It's not coming from top to bottom. Oh. As in, for this one I just defined that yes, that's what you mean, right? This one is not coming from top to bottom now. Remember the example that I gave where I said story building. You don't start from the top floor when you're in the first floor. Yeah, so you go from the first floor to the you go from the ground floor to the first floor to the second floor and look for what you want to get. Yeah, so it's not starting from top to bottom. And again, it's cascading goes from top to is it is cascading, which is CSS that goes from top to bottom. So it's I think that example that I said about cascading for CSS is in reverse. It's not actually a perfect example for it. Okay, okay, okay. So where are we now? Okay, so everything I think let me read this explanation. It is possible to write an inherited method. It is done the same way, blah blah blah. No, this part I think there's a part where they share an instance of document then I call them to this. Okay. Yeah. So let's read this part. This is the animal function. This is the bird function. And then bird inherited from animal. and then bird added a new prototype called it. Now it says if you have an instance, let dot goes to new base and you call doc.it. This is how JavaScript looks for the method on the prototype chain of doc. You see remember prototype chain now, right? Okay. So it's a doc, so it goes to doc and check if it is defined here, which is this current object now. And it sees that there's no it defined there. No. Then it goes to bed and say, is it defined here? Yes, because it is defined. Where is it now? It is defined here in bed. Yes, say execute it and stop searching. Just like when I said, if you go, if I said you go get me water, if you find the first floor, you will immediately come back. You will not go. There is no need for you going to the second floor again. Yeah. It's an animal. It is also defined, but JavaScript stopped searching before reaching this level. Yes, so you just go from step to step, from step to step with that. Now, override the fly method for penguin so that it returns the string. Alas, this is too long. So now we want to, okay, yeah, go ahead. Or, so that we don't, alas, this is like this, right? Oh, okay, it's returning, it's not console. Yeah. That's what I knew before, right? Okay. Okay, use a mixin to add common behavior between unrelated objects. As you have seen, behavior is set through inheritance. However, there are cases where inheritance is not the best solution. Inheritance does not work well for unrelated objects like birds and planes. They can both fly, but a bird is not a type of airplane and vice versa. For related objects, it is better to use mixing. A mixing allows other objects to use a collection of functions. So how do you define a mixing function with this? Let me let your variable name equals to function. Your function takes an object and then you attach whatever method that you want to attach to that particular object. So this one is fly. Get so the only difference between this and your normal function is that there is first a parent function that takes the object, and then there is now a child function that's assigned to the object. So going to this, so we have let bird equals to this, and then you have let plane equals to this, and then fly mixing, you passing the bird, which is this object. Now you can see right now there is no method defined in this bird object, right? But then when passing bird into this function that we created, this object here, the fly is attached to it and then it's assigned. So you can now call bird.fly and plane.fly. You understand? Okay. So if we are to create a mixing named glide. both of them cannot access it. Yeah, you cannot attach it to instead of us. I think you're breaking. Yeah, yeah, because they are even if they both can fly, but they are different types of objects. You understand? Yeah. Because if you have to create bird now from a parent object, you're using animal for it. Yeah. So and plane is not an animal, but then they both can fly. So you want them to both have this fly method in them. So that's where this mixing comes in. Yeah. So this is saying create a mixing named glide mixing that defines the method named glide. Then use the glide mixing to give both bird and boat the ability to glide. So this is the bird object. So this is the boat object and this is the bird object. Now I said we should create a mixing named glide. So let me bring this down. Oops, that's far. So this is the mixing. So how should I go about it? The editor doesn't do anything, so just do this. Yeah. So we define the mixing function. So how do we now apply it? Alright. Like so, yeah. Okay. Okay. So this part, at the end of the day, this is actually it's someone else here. Okay, I thought I heard somebody. Yeah, I can hear. I thought I heard someone else. Okay. So this part is actually you know how scope works in JavaScript. How scope works in programming generally. You know, right? Hello? Oh no, not again. Okay, okay, okay. So using closure to protect properties within an object from being modified externally. So I'll just go ahead and create an example. Or let me try if I can use this one. So this is function of base and then let's hash equals to this. This dots this dots get hash count equals to function. Now this returns the hash count. If you don't if I don't know if you don't but then in Java when working when creating your objects when creating your classes you always get you only all of your fields will always be private. You can't access them. You can't access them from anywhere. You can't access them externally. So you always get a setter and a getter for it. Okay, so that's like what this one is doing right now because it is within this particular fact, let me create an example. Let me show you. Let me show an example here. Let's still use this our human. Let's use this our human here. This is it. Doing that. Okay. Let me create a new let me create a new function object, say teacher, right? Teacher can take a name, then you say this that name equals to name. Now let me say let's salary. Let's salary. I can now say this dot set salary equals to. Do you understand how it function? No, no, no. Let's go value. Right, and I'll say salary equals to value. Yeah, and I'll say this get salary equals to salary. Now, you know, it is ideal to know a teacher's name, but then it is not good for you to know the salary that they are earning. You understand? You can go when you go to when you go to a lecturer, when you go to the school, you know what your lecturer's name, but you don't know what they are earning. So this is it now. We are creating a teacher's object. Now we are making the name public, but then we are making the salary protected. We are protecting salary so that if I do say new lecturer, sorry, let's lecturer equals to new teacher. I can pass the name and say teller. Yeah. Now I can do console.log console.log leg that name, and I'll get teller here. But then I cannot do leg dot salary. I can't do that. I get undefined. Yeah, because it's no longer it's no longer public. It's no longer made public to every function or any whatever. It's not gonna made public. It's not protected. So the only way I can get the salary is if I use this get out function, right? So let me first say like that set salary and pass the value, say 2000, right? Then I cannot do leg dot consider log leg dot get salary, and I get 2000. Okay, so the only way right now to access this salary field, is with this getter and setters. Without it, you don't have access to it. So that's like what's happening here. So you use closure to protect properties within an object from being modified externally. Oh, sorry to say from being modified externally. Yeah, so this one is just setting a value on its own, setting a value and hard coding the value, and then you can only get it from with this function. So here, so now you say change how weight is declared in the base function so that it is private variable. then create a method get with that returns the value of 15. So this is the weight, this is the weight equals to this. So it said we fetch change it so it's revive it. How do you go about it? Get your key from here. What should we do? Yeah, you said we have this thing. This one, the way it is right now, it is public. It can be accessed from anywhere. So they want us to make it private, just like it is here. So that's yeah, so how do you go about it? What should I do? Yeah, this one is just actually talking about the getters. I only use that getter and setter method from Java, so this one just about talking about this one just asking for get, the method to get. So what should I do now? The first part is to make it private. Is to make it private. So how do I go about that? Nah. Look at this function. Get your key from this function. This is the private field. This is the getter. So the first part is to make it private. What should we do? Nope. Nope. Calm down. Look at it again. This is a function. Yeah. Now this is the private. This is us making it private, which is what this part is asking for. Private. So what's the difference between this and this? Look out for it. Yeah. So we take out this and make it late, so that it becomes only visible within this field, within this block, right? So we've done this first part. So the next part now is to create a method get. So how do we go about that? Because yeah, so that's it. Yeah, I feel that. Or should I go by it again? Do you understand? Okay. So should I start? Okay. So if you remember, let me undo this dot weight makes it accessible everywhere. Back to this example that I was giving earlier. I created two fields here, one is salary, one is name. Now I could access salary. Sorry, I could access name. I could access name from outside this block. I could access it from outside this block because it's public sort of. This is the name equals to name. So I could do I could do this the name. Oops. I could do this and then it gives me the name teller. Do you get that? Okay, it gives me the name teller. But then I can't do that. I can't do the same for salary. I can't do the same for salary. It gives me undefined. Why? Because it's not visible outside this. It's not visible outside this object. Salary is not visible outside. It's not public. It's only made private. So this scope this block itself exactly to the teacher itself, because salary feed is kind of protected. It's not everybody that will want to know the salary of everybody. Yeah, so we protected it. I think this the role example question that you asked earlier can also come here, and you can say that okay, this field should only be called by so person who has this particular um privilege. Exactly, you get. So it's private. That's why we use let salary for it. And the only way you can get it is if you use a getter function, a function that returns the salary. You understand? Yeah. So that's come. Let me change this. Maybe this is confusing. Function. Uh, yeah. So this one return salary. So return salary. So that's why that's why when I do leg dots get salary, I can actually get the real value of salary. But if I try to access salary directly here, I get undefined. Okay. So so can you try this? Can you try this one again now? Yeah. Guess what? Okay, before the arrow function. Okay. Yep. Yeah. We're almost there. You try it really. I think just two topics more. This one and one more, and then we're done. Yeah. You tried. I mean, you really gave it your time. Well done. So so understanding the immediate invokes function expression. This one is just basically English. What I said is that if you have a function with two parentheses, it will automatically call. That is what they are saying. So a common pattern in JavaScript is to execute a function as soon as it is declared, just like you see here. So this is an anonymous function expression that executes right away and outputs chip immediately. Notice that the function has no name. That's one thing you need to take note of. And it is not stored in a variable. The two parentheses at the end of the function expression causes it to immediately execute or invoke, to be immediately executed or invoked. This pattern is known as immediately invoked function expression or IIFE. Now, our task right here now is to rewrite make next function and remove its call. So instead of it, instead of an anonymous, just wait already. We rewrite the function make next and remove its call. So instead, instead it is an anonymous immediately invoked function expression. English. So basically, they are saying that what we see here, we should convert this function to look like this. Two things that you should note is that it is wrapped in brackets, and then there is another bracket outside it, and then it is an anonymous function. There is no name. So what should we do here? Hello, hello. Yeah, I can hear you now. Okay. Uh, okay. Okay. Yeah, that's good. Right. That's it. Very sweet. Now the last topic. Use IIFE to create a module. An immediately invoked function is often used to group related functions into a single object or module. For example, an earlier challenge defined two mixes, glide mix and fly mix. We can group these mix into a module as follows. So the only thing that's different from what we did before is this time there is a variable, but then it is still wrapped in brackets like normal. Yeah, but then also there is an object that's being returned. It's an object that's returned. Yeah. So um how can we do it here? Do it here now. So we are saying that we should use it's for creating modules. No, no. If you want to create a module, like basically that's what we're using an IFF to create a module. That's the topic. We're using to create a module. Yeah. So what should we do? Well, let's immediately the question. Say create a module, then fun module. So we have two mixes, is cute mix and sync mix. Fun module should return an object. So what should we do here? How should we start? I think this fun module. Okay. So let's let's this. Mm-hmm. You know what? Yeah, hold on. Hold on, let me bring it down so it's clear. So let's module equals what? Okay. Yeah. Exactly. Exactly. Yeah. Yeah. So mm, yeah, I will just basically convert it to a function. I mean an object rather. Basically just convert it to an object. So oops, oops. Okay. So basically just do this, right? And then I'll come back here and copy this again. So yeah, this stuff. Copy this and then paste it here. Yeah. So okay. So you understand, right? It's basically just an object, and then there is the key, and then the value is the function itself, and then there's another key, and then the value is the function again. So they accept it. You like you cannot do say maybe if you have an object already like say bed bed equals to this, yeah. So you can say this dot which of the functions you want to call and say is cute. Exactly, so you pass it. You remember the mixing that we did where we had to pass an object so that they attach something. Yeah, so it's just basically the same thing, just that this time they are grouping different mixins in an object and then returning it as one single object. So you just need to say this is how you call it. So right now, bed now has this what's it called? This cute. Yeah, it now has this case and it now has this cute function attached to it. So I can now say bed dot is cute. I can now say bed dot is it cute or cute? Is cute. Oh man, so that's the last one. Yeah, that's the last topic. And then we're into function one. You say? Alright. Thank you. Yeah, no, so and yeah, no problem. No problem. Yes, I will.